All right, thank you for joining us. This is Ken Abear, and I'm the National Sales Manager of Malta Dynamics. We are a fall protection manufacturer, and we have a course, and we make these courses and presentations because we get so many questions, and so we want to put them together, and I'm presenting this for a group today, and we're going to record it as well. And today's course is on fall clearance. Fall clearance is something that is a very, very simple calculation. It's something that's required to be taken into consideration on every job site. It's something that is by law required to be written out as part of your fall protection plan. So, as we usually do, please save any of your questions till the end of the presentation, and then I'm going to make myself available to answer them. And of course, my contact information is below. So let's say you're driving down the street in a couple of weeks and you think of a question, you are more than welcome to give me a call or email me, and I will do my very best to answer the question that you've got. So let's get started on fall clearance. This presentation does not replace fall protection training approved by your safety director. It bears repeating, of course, that your company and employer is ultimately responsible for your fall protection plan and your safety. So you take your orders from them, not from any third party, including ourselves. Fall clearance. OSHA requires a fall protection system when working above 6 feet. Most people know that. Calculating fall clearance does not have to be complicated. It can be very simple. And here are the 5 things that I want you to make sure you factor into your formula. The length of fall protection system. So are you using a 6-foot lanyard? Are you using a 50-foot vertical lifeline assembly? You have to know what you're using. The other is really, now we get into the formula: height of the worker, free fall distance, deceleration distance, and a safety factor. So remember those 5 things, and really the calculation that I run usually involves the 4: the height of the worker, free fall distance, deceleration, and safety factor. So factor 1, length of the connector system. So if you have a 50-foot vertical lifeline and you're in your means and methods or in the written fall protection plan for this job site, you're telling everyone they want to extend that out to 30 feet. That's the most you're going to allow them to use in their VLA. Then you need to deal with 30 feet as your potential fall. Okay, if you have all of your workers on 6-foot lanyards, then you need to be dealing with 6 feet as your length of connector. But that's factor 1. Height of the worker. Height of the worker is important. Now this number will vary. A lot of companies will just make it mandatory that they put height of the worker at 6 feet. But in reality, the height of the worker varies. It varies on where the D-ring is on the back. It could be very possible that the height of the worker is going to end up being at 4.5 feet or 5 feet. But you want to give yourself a little bit of leeway, so 6 feet to me makes a lot of sense. Then we have free fall distance. So I want to explain this. This is the distance before the fall protection system engages. Now OSHA requires that the longest you can allow someone to free fall is 6 feet. That's why you have lanyards made at 6 feet or less. Now a fall on a retractable, right, that's going to catch you in the first foot, 1.5 feet, maybe it pays out a little bit more. If it's Class A retractable, it's going to be limited no matter what circumstance to 2 feet. So you're going to be caught at 2 feet. If you're in an aerial lift and you're using a 4-foot lanyard, then you're only going to fall 4 feet. But you have to know how far the person can fall without the system engaging. Okay, and that's called the free fall distance. Then we have deceleration distance. So when your free fall distance stops, your deceleration distance begins. That's when the shock pack on your lanyard begins to open up, right? It kind of blows out of its plastic case and begins to rip apart. And that process of ripping apart slows you down. That's absorbing all the impact forces and the arresting forces, I should say, that would be occurred on the body. So it's slowing you down to get you under 900 pounds of force. And I'll read the definition here. The distance during which personal protective equipment, such as a clutching, self-retracting lifeline, works to decelerate the fall and arrest the fall. So I hope everyone understands what deceleration distance is. So you got the height of the worker, then you've got the free fall distance, and then you've got the deceleration distance. If you're using a regular shock pack lanyard, you've got a free fall of 6 feet, and then you got to add 3.5 feet on top of it. So we'll get into that right now. And then we have a safety factor. You always have to put yourself in a buffer. Just like the height of the worker, we put it 6 feet, even though it may only be 5. We put it at 6, just because we want to err on the side of caution. The safety factor is the same thing. Some companies I've seen use 3 feet. Some companies use 3.5. Let's say 3.5 feet for our purposes. Now here we have a guy on a rebar hook, and we're going to watch him fall. But he was saved, and he only fell a little way. So we put that in there for your enjoyment. Here's an example of a lanyard. So we have a 6-foot lanyard. Here's the worker working. Okay, 6-foot tall worker. So there's the distance that he's going to fall. The shock pack begins to open up for 3.5 feet, and there he is, taking up an additional 6 feet. So you got to make sure, right? If you're only 12 feet off the ground, this guy's legs are going to hit, right? And there's your safety factor. That's why you put that buffer in there. But you have to be 18.5 feet from the anchorage. It's not from where you're standing. That's a common mistake that people make. You may want to take a note of that. It's from the anchor. Your fall distance, your fall clearance has to be from the anchor point. Let's go to another example. Here's another example with the lanyard. Now, this guy's making a mistake. Now, sometimes job sites, you have to put these at your feet, but this is going to create some additional problems for this worker. So it's still 18.5 feet. Everything's the same, but look, he's going to be closer to the ground, right? So it's below the anchor. So if you always use the anchor. So if you are more than 18.5 feet, I'm sorry, if you are less than 18.5 feet, you cannot use this in that situation. You can't use a lanyard. And many of you already know that regular lanyards are being replaced by self-retracting lifelines, SRLs and SRDs all over the country. And here's our buddy again. He's on an SRL now, but he's smiling because he's saved. All right, now here's the SRL example. This is a Class A application. So there's going to be 2 feet that this SRL is allowed to pay out. Now, here we have a much better scenario, right? We have a 1 foot free fall distance. So that's all this guy's going to fall before it engages. And quite honestly, between me and you, it's not even going to be a foot. But go ahead and give it 1 foot, err on the side of caution again. And then you have a 2 foot deceleration distance, because that's how far out a Class A retractable will allow you to go. It says, to be honest with you again, in good conditions, it's not even going to pay out that much, but you have to give it that, because a Class A retractable in the write-up and evaluation to meet the Class A certification, you can only pay out 2 feet. And since it will say 2 feet on it, you have to give it 2 feet in your calculation. Then we have the distance off center, right? So this is kind of a swing fall conversation. He's not directly under his anchor point. So you have to add the 2 feet he's over here, because when he swings back in under the anchor, remember, you always end up under your anchor unless you hit the ground, and that's keeping you from doing that. But you have to add another 2 feet. Guess what? If the guy walks 10 feet away from his anchor, and he's 10 feet away from directly underneath the anchor, you have to add 10 feet to it. So you have to be very aware of where your guys are working. And then you have, of course, the 6 feet of the height of the worker and the 3 foot safety factor. So we're looking at 1, 2, 3, 9, 12 feet. So 12 feet in this case, much better than a lanyard. And that's why many companies are going away from them. Now, Class B allows you to pay out 4.5 feet of deceleration distance. So even though I could promise you, well, I can't say I promise you, but I would be willing to bet that if you took 20 Class B retractables, put weight of 310 pounds on them, and drop that weight, it wouldn't pay out to 4.5 feet. It would be less than that. But because the label says 4.5 feet, that's what your calculation is going to read. So you have your free fall distance of one foot, the 4.5 feet because it's a Class B retractable, your distance off center, right? That's going to add a little bit. There's your height of the worker. There's your safety factor. Now we're talking 4.5 feet. So this is an unknown on this graphic. The distance off center may be adding some additional feet to that. Does everyone understand that? That's a calculation you have to take into consideration when you're analyzing the hazards and then figuring out where your people are going to be working and how far away from the anchor point they're going to be able to walk, which should never be more than a 30-degree cone. And then we have the dreaded SRL at using it at your feet. Okay, this kind of kills all the pluses that you had by selecting an SRL and not a lanyard are gone. Right now, you're going to have a fall. You're going to have a full-on 6-foot free fall distance. Most likely, you're going to have your typical Class B 4.5-foot deceleration distance. There's your 6 feet for height of the worker. But now we have an additional problem. We have a leading edge scenario. So tying off at the feet is always dangerous. If something bad happens, it can get very ugly. We always recommend that you tie off overhead, obviously. But there's your calculation again. Let's keep going and let's see how this guy does this time. He's safe. And we have another one, and he's going to be safe. He's in an SRL. He's safe too, but he has a swing fall, and he's not coming into contact with that edge. So I guess it's not a leading edge scenario. So it's easy math. Remember this. Lanyard fall clearance is always the same. 6 feet, 6 feet, 6 feet. If it's a lanyard, it's 6 feet. Self-retracting lifelines require careful calculation. You have to take into consideration where it is. You have to take into consideration how far underneath the anchor people are going to be able to move away from it. And you have to identify whether it's a Class A or a Class B. So SRLs will create change within your fall protection plan. Other considerations: always assume the fall arrest system will fully deploy. A 20-foot self-retracting lifeline can deploy up to 20 feet. This is not good information for us to go over. And when I say that, I mean, I don't like reading it, but it's true. So our engineer put this in here, and I was talking to him about it. What he's saying is if you have to have a plan for 20 feet to pay out in your self-retracting lifeline, because that's how long the cable is. However, in most of the calculations that are run, you're looking for fall clearance that if everything works the way it's supposed to work, that's the numbers you're going to go with. So if it's a Class A, it's going to be 2 feet. You're not going to say it's a 30-foot retractable. I'm going to make sure there's 30 feet of clearance, right? But you do have to know. You do have to know that if you're working a horizontal lifeline, and we don't have an example of this, that once that braking mechanism locks in, if someone fell and that horizontal lifeline was too tight and they bounced back up and that braking mechanism released again, now you've got an SRL that's been used, that's just released its cable, and it's going to be asked to catch the guy again when he bounces back down, if that makes sense, if you're following what I'm saying. So you do have to take it into consideration. Lighter workers may not engage the fall arrest system quickly. So, you want a lot of our products that we make, we test on guys that weigh 130 or to 310 pounds, up with ours up to 420 pounds. But you got to take that into consideration. Putting a 110-pound guy is a no-no. Read the labels of all the product. Because it changes the way the stuff works. And pay close attention when working with shorter fall distances. If you're 12, 13, 14 feet off the ground, you need to figure out how you're going to approach it. My name is Ken Hebert again. I hope this was useful to you. If you have any questions, please give me a shout. It's khebert@maltadynamics.com, or you can call me at 832-683-6218. Thanks.